So I want to talk a little bit about hyperspaces. Now, the trouble with hyperspaces, there's only two kinds of people that seem to be able to reasonably deal with hyperspaces. Mathematicians that have special training, or small children. They have no problem with this sort of thing. Now, let's back up and talk with Euclid. Euclid's writings are probably the most widely circulated and popular for the last 2,000 years, second only to the Bible. And I'd like to just talk a little bit about trigonometry. Let me ask you a question. How many of you know how many degrees are there in a triangle? If I take a triangle, typically say a 30, 60, 90 triangle, and add up the degrees, it adds up to what? 180 degrees, exactly. If I take a 45, 45, 90 as another example, again, the angles of a triangle add up to 180 degrees. That's how many knew that? Okay, good. Well, suppose Dr. Eastman and I walked out into the large desert area out here and laid out a very large triangle. And as we compared our calculations, we discovered that our angles added up to more than 180 degrees. What would you conclude? That we screwed up again. What you'd expect from Chuck and Mark, right? No, if we have a triangle that adds up to more than 180 degrees, and we check our figures, it's accurate, what have we encountered? The curvature of the earth, exactly right. In other words, a third dimension. See, these little rules that we learned in school have to do with plane geometry, a geometry of only two dimensions. If you take a course in navigation, you encounter spherical trigonometry where you can have a triangle with 90 degrees in each corner. And again, this is a way that we encounter an additional dimension. A three-dimensional triangle obviously can have degree. In fact, that's how you know it's three-dimensional if it violates that original geometry. Now, that's the kind of insight that led to Dr. Einstein's solutions as he grappled with the nature of our reality. Most of you know that in 1905, he had a special theory of relativity in which length, mass, and velocity and time are relative to the velocity of the observers, the famous initial step at this. And it was a few years later that he generalized this theory, and he discovered that there really is no distinction between time and space. If you're really properly briefed, you will always speak of space-time. We don't do that. We're comfortable with three spatial dimensions and time. We treat them separately. But we know in modern science that we live in at least a four-dimensional continuum. And by the way, this has been confirmed 12 different ways to 5 decimal places and beyond. In fact, I understand recently an experiment confirmed it to 14 decimal places. So the point is, they're really, while we call it the theory of relativity, it's far more than a theory, it's well confirmed. Now, this leads us then into the whole area of hyperspaces. You and I would tend to be most comfortable at visualizing this as three spatial dimensions, length, width, and height, and time. But time itself is a physical property. And in particle physics today, if you're currently reading particle physics, you know that they have concluded that we actually live in 10 dimensions. And it's interesting that that was perceived by the ancient Hebrew writers from Genesis chapter 1. But rather than do our homework in Genesis 1, we've spent billions of dollars on accelerators to determine it the hard way. But in any case, now the reason we're getting into this today is I think it's going to be useful for at least to consider the possibility that these UFOs, and more importantly, their occupants and whatever, are coming to us not from some far galaxy, although they seem to be posing as if they are, but they come from another dimension, and that has profound implications for you and I. Now, we have trouble going up in dimensions. If I start talking 4 or 5 dimensions, you and I will be at a loss because we're not specially trained in that way. But we can gain some insights by imagining something less than 3 and drawing some inferences. Let's imagine a world that has only 2 dimensions, like a plane. Let's imagine in our imagination that there are occupants with two-dimensional occupants within that two-dimensional plane. Now, if we came along as a three-dimensional person and put our finger through that plane, what would the two-dimensional people in that two-dimensional world observe? A circle, or a hole, yes, in a sense. Right, exactly. Let's take another example. if a three-dimensional sphere is passing through that two-dimensional universe, it will appear as a point that enlarges to a circle and then that reduces back to a point, because they would be perceiving a two-dimensional slice of that three-dimensional object passing through. Are we together? Now, let's assume we didn't have a circle, we had some other kind of an object, here represented such as a cube. If that cube tumbles through that space, not only will it start from a point and get big and then shrink, it will change shape as it goes through, and depending on how it's being cut by that plane. Are we together so far? There are many. Jacques Vallée, who's probably one of the most prominent published people in the UFO area, has suggested that these UFOs may be windows into another dimension more so than objects. And you and I have a tough time relating to that, but he may be very, very correct. Let's assume that we were trying to communicate a three-dimensional object to a two-dimensional world. We would be asking that two-dimensional world to encounter things that they don't encounter in their experience. Our imaginations are generally limited to our own experiences. One way we could try to do it if we had a cube would be to project that three-dimensional image into a two-dimensional space and maybe rotate it, but its behavior in the two-dimensional space would be bizarre to the two-dimensional occupants in any case. Now, another way we could do that would be to take a three-dimensional cube, say, and unravel it into two dimensions. And we would take that two-dimensional cube and start to unfold it and lay it out flat. And that would be a way, possibly, to try to get a two-dimensional being that we're communicating with to recognize what a three-dimensional cube might be. But all of these are very imperfect because we're asking that two-dimensional being in a two-dimensional world to extend their concepts into a dimension, into a region that they have no experience with. Now let's take another example, and that is there are such things as hypercubes, a four-dimensional cube. How do I represent a hypercube in the three dimensions? One way is to unravel it, and one suggestion is what's called a Hinton cube, which is an unraveled Hinton cube or a hypercube called a tesseract. And even you and I look at that and have a tough time trying to relate to a four-dimensional cube. You say, well, what practical use of it? Interestingly enough, Salvador Dali used that tesseract, a four-dimensional cube, in his famous painting of the crucifixion. And we'll come back to some of these issues a little bit later. What we've done here in just a little tentative exploration is go beyond Euclid, and we like to talk about more than three dimensions, hyperspaces. It turns out the most important lecture ever given in history, history of mathematics, occurred in June of 1854, when George Riemann, who was a pastor's son, by the way, developed a set of mathematics, metric tensors, that opened our thinking to be able to represent meaningfully hyperspaces, spaces of more than three dimensions. And that it took about 60 years later that Einstein, exploiting those concepts, developed his four-dimensional space-time. Now, the irony of Einstein's life is he went to his death frustrated by not being able to relate gravity and light into that region. And it was actually in 1953 that Kaluza and Klein together developed by extending another dimension. Light is basically a vibration in 5 dimensions. Light and supergravity have been integrated by the Kaluza-Klein models, which are basically extending this four-dimensional space into more than 4, 5, 6, and so forth. And in 1963, the Yang-Mills fields, extending it even further, have integrated electromagnetic and both the nuclear forces, both the strong and the weak nuclear forces, for those of you that are familiar with physics. There are 4 basic forces in the universe, and 3 of the 4 have been integrated by the techniques. Now, the current thinking from about 1984 on is that the universe actually consists of what the mathematicians called superstrings, and that they actually involve 10-dimensional mathematics. Now, it's not our purpose here to get into this area, because there's 2 kinds of people in the audience, those that are familiar with this, and those that already have learned more than they really want to know about hyperspaces. But I want to mention this because there seems to be good evidence from the reports that these encounters that are going on involve hyperspaces. these UFOs and their occupants not only are clocked on radar and elsewhere at making right-angle turns at speeds that are incredible, which imply they're massless by our physics. They also go faster than the speed of sound without sonic booms, and that's a disturbing thing. But what's most disturbing is they seem to have the ability to materialize and dematerialize at will. And that disturbs us. It makes them seem very, what we would use the term supernatural. But that supernatural term may be derived only because of our limited understanding of nature. And let's move on a little bit.